So here's what we did last time. What we started going into was the fact that you can have some kind of query. Let's say quote query of person. Right? So you can take this thing, you can reason about it, you can translate it into an AST. So for example, let's say this is filter p2p.name equal to John, or something like that. Now, this is a macro, so it doesn't just see the result of this expression. It sees the entire expression, which actually means that when you write query, like what does query look like? At some point, there's this thing called DSL, or domain-specific language. And then, at some point, you have to actually define this thing here, right? So you do def query of some t. Okay, well, it has to return something. It has to return, this has to return something that you can do dot filter on. Okay, so let's create a type called query. So then we can create class query. And then we can define filter. And then this is going to have some type, and this is going to have element of type t to some Boolean, right? Because that's the Boolean filter you've got in there. What does this return? Well, it returns query of t. And you've got all sorts of other functions, like you could do .map. You could do .map to, let's say, person.name. Okay, so we could define map. Map of t, element t, o. Wait a minute. T should technically be defined here on query, right? Because what this thing should return, is query of person. Okay, so actually t has to be on query, right? So t is not supposed to be here, right? But what about for map? The query that gets returned, let's say, question mark here for now, person.map p2p.name. Name is a string, therefore that's query of string. So this is an output type, right? Because this used to be this, right? We can replace it. So this is output 2, right? We can replace it with that. That has the same meaning. So this has to return a different type. So t to r, and this thing is query of r. Okay. There are some other things that we can do here, like, let's say, flat map. And instead of p.name, we could do p.join. with potentially some other query of address, maybe on a particular field. So but wait a minute, it's going to be p2 p dot join. Let's remember what this actually looks like for a second. In this form, right, that's going to be p2 query of person, and then it's going to be a to query address dot join, and then that's going to be,
p dot name something. Oh,
a2, well, we need a new a that we declare for this join. Let's say p dot id equal to a dot some foreign key. Right, so this is going to be query of address dot join, and again, a to p dot id equal to a dot fk, right? This is the desugared form of this part here.
Desugared.
Right? Because this is the for loop. The for comprehension is just syntactic sugar for flat maps. Now we actually can yield something like P and A here. And then what ends up happening is that this would be, at the end of the day, it would be like a map. And then we would have address that would be the result of coming out of here, right? And then A, and then we could do P and A, right? This is actually a little bit easier to see when you start indenting it. So then we have blah, blah, blah. Of course, again, quote has to be around this whole thing, but let's cut it off for a second. Query of p dot flat map, and then p to p query of address. Let's do this. P to query of address dot join, and then eventually, yeah, let's do it like that, and then eventually dot map on top of that. Let's put the map over here. Let's put that parenthesis there and that parenthesis there, right? So this is the desugared form of this. Because the for comprehension is just syntactic sugar for flat map and map, right? These are monads. Query is a monad. But anyhow, this is, again, I urge you to play around with this. In particular, in IntelliJ, we have this wonderful thing, ID int case class address, let's say foreign key int street string, right? And then we can do something like query person for P2 query person A query address dot join Let's do yield and empty for a second. Dot join A to A to p.id equal to a.fk. Let's say yield p and a. And if you take this entire thing and you go to code, desugar Scala code, then now you have to unclick everything here to tell it to not desugar anything other than expand for comprehensions, and that's the only thing you care about. And voila! Right? It's syntactic sugar. I am not lying.
It's sweet.
Right, so this is a very useful feature of IntelliJ. But anyway, so this is flat map, right? In this case, flat map is going to take us to val output is going to be query of tuple, right? Because we're returning person and address. Right, so there's your return type. Okay, that sort of works. But we could make it easier and just return address. In SQL, that doesn't really have a meaning. It's like we're joining two tables and we're returning only the second one. Okay, whatever. Right, select a dot star from person join person p join address a on a dot p on p dot id equal to a dot fk, right? That's the equivalent of this, right? So we're just selecting the addresses, but whatever, let's make it simple. So then it's just going to be query of address. So then we can just say map 8a. And then if you do it through a for comprehension, that's what it's going to desugar to. If you're doing it by hand, you can get rid of this map entirely. So then it's going to be something like that. So now we've flat mapped, and the output is query of address. So again, def flat map has some return type. And then inside of here, what ends up happening, we have this whole thing here. Okay, well, this join thing here, let's get rid of that, sorry. Let's look at this thing here, right? This is going to equal to that. And okay, so then what's this join going to do? Imagine we get rid of this join. Well, let's take a look at the SQL query again. Let's copy that. Here's our SQL query. What happens when we get rid of this join? Well, what happens if we get rid of this join and just do select person address? What happens then in SQL? Thoughts?
Well, it's the same thing. Oh wait, no. It's a join, but without any condition.
Yes.
So it just it's what's it called? It's a union? No. That's the word I'm looking for. It's
Cartesian product.
Yeah, outer join. Yeah.
Remember, every single join in SQL is just some subset of the Cartesian product.
Right.
Right. Let's say that there's Joe. His ID is 1. Jack. His ID is 2. Jill. Her ID is 3. There's 1, 2, 3, street, which has a foreign key of 1. 456 street, which has a foreign key of 2. 789 street has a foreign key of 3. And let's say we have another 9, 10, 11 street that has a foreign key of 3 as well. What's the Cartesian product of these things going to be? Well, it's going to be every single one from this set combined with every single one in this set. So we're going to have Joe 1, 2, 3, 4, Jack 2, 2, 2, 2, Jill 3, 3, 3, 3, right? And for each one, we're going to have this entire set, right? Oh, whoops, let me. Right, let's do that. Right, so this entire set.
No, that should still work. Just you just need 4 cursors, and if you copy that,
No,
work.
it's home and end. It's just my home and end keys are different from the way that I want them to be, but it's fine. Okay.
Oh.
It's the selection that's... There we go. I just have to change the key shortcuts here. Okay, with these, right? That's the Cartesian product. That's the Cartesian product of all this data. What happens when you actually do a join by this ID? Well, it'll cut out these 3 rows since Joe is 1. It'll cut out this row and this row and this row, and Jill has 2 addresses, right? So this is the result of the join. This is the Cartesian product. A join is a subset of the Cartesian product.
Wait, Alex, but in this case, we won't even get the persons, right? Since we're only selecting the addresses.
Ah! In this case, we're selecting the addresses and the Cartesian product. So what we end up getting is this.
Just without the persons, I guess.
Yep.
Just multiple, yeah.
Yep.
Makes sense.
Right, we just get that. Right, that's what we're going to get. And
list of address 3 times.
Huh? Yes, exactly.
Okay.
Except for the one that's 4 times, but or yeah, you're right. Sorry, each address 3 times because there are 3 people. So, and then, right, but that's the same thing as getting rid of that. Again, now this is equivalent to this. Okay?
Mm-hmm.
Let's take all of this and continue from here. So, flat map also has a return type, but this, right, this is actually of type query address. Right, we can add a random type description like this, at least according to Scala, we can. E goes from T to R. Does it go from T to R? Remember that when we did map, we went from person to p.name, and this was p.name, this was a string. Right, but this is address. It could also be something else, right? Let's say that we could join it up to a query of some string. That's how you could actually contrive something like this. Is a little crazy, but actually, let's see a simpler example. Imagine that, let's say case class person, and then let's say we had ID int, name string, and an embedded address. Like we had an embedded address entity, right? That's a less contrived example. And then we could do, in map, we could do dot address, and that would be of type address. That's what we mean when we say something like this. Right? Of course, let's pretend that in this situation, there's no embedded address, which is why it needs to be joined from another table. By the way, if you have an embedded address, each person can only have one address, right? So, okay, fine. But now notice that this is query of address. A flat map ultimately turns you into something that's query of address versus a map that turns you into address. So this is going to be T2 not R, but
Query of R.
query of R. Turns into query of R. Right? The net result of this is query of address. Okay. So we're writing a whole DSL for query here. Right? It's a monadic DSL. Flat map, right? This is a monad. Query is a monad. Okay. Here's the trick though. And let's keep this map part of it. Here's the trick though. What's the implementation of this? What's the implementation? Well, remember that this is actually quote. And this is actually quote. And this is actually quote. And this is not query. This is quoted of query. This is quoted of query. This is quoted of query. So what's the implementation? And if you want to answer that question, tell me this. When is this going to be run? When is this statement executed? When is this statement executed? When is this statement executed?
Wait, I thought the idea is to not execute it.
It is not.
Oh.
It is not. So the implementation literally is throw new illegal argument exception cannot
Run.
Cannot use during, cannot synthesize or something like that during runtime. That's the actual implementation. The implementation is throw an exception, because these are not methods that you call. These are methods that you parse. What is quoted? What is quoted? Right? Well, we discussed it last time. Quote is some kind of object that has to store the AST that's a result of this. So in this case, it's going to be something like, let's say AST is going to be query of person. It's actually a little bit more complicated than that. because query is an interface, and what we actually have is we have a class called entity query, and the other kind of query that I have not discussed is where you can do something like quote of query of person dot insert p, or lift of p, which is a lifted external variable. Right? So entity query has a insert method. This is
t. Alex, just a small question. About just a small question about the implementation of the query, like all those methods. So if you actually take the query of person outside quote, it'll throw this exception, but anything inside the quote or anything inside the quoted never gets executed.
Right? No, it never gets executed.
All right. Okay. Cool.
That's parsed.
Yep. Cool.
So anyhow, entity query has some additional methods. Now, you can't do that when you start flat mapping things. Like, you can't do something like flat map and then do some kind of join in here and then do an insert. Right? That's the DSL, the Quill DSL doesn't support that. But anyway, that's just why there's this other thing called entity query. But let's pretend that it's query. Right? So, okay. So this is the actual DSL. Let's pretend that it's a class. Right? This is the actual AST. Right? Let's see, when you do a filter, again, it has to return a quoted object. And then in here, it's going to be because we're mapping, right? We're mapping here. So this is going to be map. And this is going to be a function. So this is going to be, what does the AST for map look like? Ident of P2 property. Ident of P2 name. That's what map is going to look like. Let's say we have something like filter. P.name equal to John. Right? Well, that looks almost like this. It's going to be same kind of thing. Query, ident of P, but we have this equal. So that's binary operation of property, operator dot equal. Again, this is just an object. And constant John. Right? So that's what the quoted ASTs look like.
And that'll be filter.
Yeah, that'll be filter.
Oh no, indeed.
Correct. Right, so that's what the Quill AST looks like. The Scala AST that needs to be parsed is substantially more complicated. Right? In this case, it's going to be something like DSL.query. So the Scala AST is going to be something like select ident DSL, which is this thing here. And this is probably a string inside of here, but not necessarily. It's more weird complexity inside of here. Let's not go into that. Just put these things around there. In fact, I don't even want to do that. Let's just pretend that this is some other thing. Select, what are we selecting from? We're selecting query. Now, again, if it was query of foo, it would be apply to a list of arguments, a list of foo, but it's a type. It's a template. So it's actually type apply, because we're applying a parametric type. This is going to be like type of t. And again, there's more complexity here, but that's the general gist of it. So that's what this is, right? So we take this, which is really this tree here, and we parse it. But by the way, this t, by query, it's actually going to be query of person, because that's how we define it. We actually type it. It's going to be type person. So we take this whole thing here, and we parse it into this thing here. In a quasi-quote, using a quasi-quote, the way that it's going to look like is roughly like this. So it's going to look like query, right, DSL dot, but we can like make a variable for that because whatever that is. Query of type. That's going to be the quasi-quoted syntax. So this is what we parse into that. And we can actually look at parsing, query, there it is, right there. Pack. Okay, right, we call this pack. All right, so there's that. Pack.query of t. Right, that's the AST. So what do we do to parse to get this AST? It's the job of the parser to get from here to here. How do we do that? How do we get from here to here? Well, that's it right there. That's how we get to the AST. That's how we get to entity. Right? We're parsing it. So this expression is what gets parsed. What do we want to talk about next? Let's compare it to what happens to Dotty, right? So this is the quasi-quote. Now, something important to mention is that, remember how in the old Quill, right, it's something like that. And this is a refined type. Remember what we covered with refined types? That's,
Yeah.
right, where we had something like, and then when we did this, oops, gotta import the context. So remember when we did this, right? This is a refined object, a refined instance of quoted. And then this is going to be the actual, this is, well, here's the AST. That's the main part of it. There are some other things here to consider, but this is the main part. So it's a refined object. in Scala 2. In Dotty, however, we do not need this refined type mechanism anymore, because instead it will be a inline def. Inline, what inline means is that whatever comes out of here, we preserve the syntax tree without executing it. So what we do when this happens is that we actually take this thing and then we parse it into this thing. But really, what we do is we translated it. We need to return this thing, right? We need to return it into the output. But here's the trick, and this is actually the problem. This is the problem that we've got here as well in Scala 2 as well. This is the problem that we've got here, which is that when we need to return something from our macro, internally we have this parser that goes from this quasi-quote and returns some kind of thing like that. Our parser does this somewhere. This is what our parser does. And then it returns us this object. Well, there's kind of a problem.
Mm-hmm.
Can we just return quoted? Can we just return that? Can we just return a new instance of an object from a macro? Can we do that? Remember when we played around with macros, remember what we had to do here.
Oh, we actually had to return a quote.
Yeah.
Because the AST, yeah, that makes sense. Or like, yeah.
Right, or let's take a look at macros intro. Right? Same kind of thing. Right? We had to return an expression, right, which was a quote of some kind, right? We returned that. Right? You can't return executable instructions from a macro. A macro doesn't yield executable instructions. A macro yields code. Right? Macros cause code to be returned. So this is like a substantial issue. How the heck, if we want to return the parsed abstract syntax tree, which is this, and we want to store it into some kind of object that we call quoted, because quoted contains some representation of what went on between this squiggly and this squiggly, and that representation we call the Quill abstract syntax tree, right? And then potentially we're going to use this quoted block and plug it into other quoted blocks. Oh, but wait a second. we can't return executable instructions from macros. We have to return expressions from macros. Okay. Well, we know what do we do? Well, we could, let's say we're using quasi-quotes. We could return new quoted, and then def AST equals to, what do we put here? Right, the parser is going to parse this into this object, right? So we're going to have this object coming back from the parser. And here is what that's going to look like. It's in this case, it's an entity. Keep in mind that this is of type query, but we actually don't parse it into a query. The AST is not query, the AST is entity. Because this is just an object that defines a DSL. We don't actually use this in our AST. Our AST is going to consist of not query, but a whole different set of entities that we define. Because this object that we've defined here is just for the sake of being able to write what's in here, but what this gets parsed into is a completely separate thing. Does that make sense?
Yeah.
Right? So we parse this into that, right? Map is a function here, right? But map is actually an element that represents this clause, where the left-hand side of the map is this first element here. The variable used is this middle element here, and this final piece here is this element here, right? So we use map to capture this kind of tree. To capture this kind of tree, we need an element. So we call it entity. Remember how this actually does not yield query, it yields entity query? That's why we call it entity. But anyhow, entity query, again, has other things in addition to the things here, like the ability to insert stuff. But anyway, so our problem is still this. Our parser has returned to us some runtime object. Some runtime object. How do we get this runtime object that we do not know? Like, the parser doesn't actually, we don't know the runtime object that the parser is going to return, right? The interface, right, the interface to a parser is a tree, right? A Scala syntax tree. The output is a Quill syntax tree. So calling this expression on the parser here is actually, the real thing is called parse AST. Or sorry, AST parser. Or AST parse, yeah, excuse me. AST parse, let me double check. What's the AST parser, excuse me. AST parser, right? AST parser takes a tree and it returns an abstract syntax tree. So calling AST parser on this will return entity of person. But we don't know that in advance, right? This is the actual type signature of AST parser. When we invoke AST parser, we have some object, which is Quill AST, which is of type AST. how do we take this and actually plug in what has to go into this quasi-quote? How do we know that we actually need to have entity, person? Oh, by the way, sorry, it's not entity person. It's going to be like entity and person is going to be the table name, so this is going to be a string. Like that. And in case you're wondering, I am not lying to you. Well, I'm partially lying to you. I'm omitting the fact that there's this other argument, not necessary for now. Anyhow, entity of person, right? How do we take this thing, which we don't know is actually there, right? We need to express this. We have this. How do we get that? Right? Even if we had, you know, actual AST, even if we had that, right? What we want is that. Excuse
me. Can you repeat that again? What do we have and what do we want?
What we have is this, right? What we want is this, so that we can plug it into here, right? Because what we actually need is that, right? This is what we actually need, because this is the code that we have to emit, right? Like this is an expression of quoted, of query, of person, right? That's what we have to return. So how do we know that we have to synthesize this code, right? If we can just synthesize this code, we know that we're returning a quotation. We know that we're putting this thing into an AST element of a quotation, right? Because that's always the way it's going to be structured. But how do we synthesize this? Right? Like, eventually, somebody's going to call run, and this quasi-quote, run is also a macro, is going to go into run, and that's going to pull out entity of person from here, and it's going to turn it into select star from person. But run actually needs to get this code in order to be able to parse it, right? Run needs to be able to also get an expression, right? Because run is also a macro. Run does not evaluate this expression. Run parses this expression and learns that it's a person table, right? The same way that quote parses this expression. So when we do something like val output from here and put output into here, right? The value of this is actually that. The value of output has to be a syntax tree. Again, it can't just be some runtime expression, or else we can't get the query during compile time. And by the way, that's the whole reason why we need to use refined types in Scala 2. Because if you have a refined type, then what you could do is you could preserve this tree. It's a little bit more hacky than that, actually. What you can do is you can take this thing, and make an annotation, and you can store it in here, but more details. They're not very pertinent. This mechanism works differently. You don't need all of that in Dotty because you can have an inline def. And in that case, what you can just do is you can store, instead of having to do that and putting this onto some weird refined type, what you could just do is you could return quoted, and quoted can be a case class. So you just do quoted or new quoted or quoted.apply, whatever. And then what you can do is you can actually take this thing here, and you can do AST equals to that. Let's do new just for the sake of understanding. Right? And then this is going to be inline def output. And so inline means take the actual syntax tree of this, store it into that, or the actual syntax tree, when I say that, I mean this, right? The actual syntax tree that comes out of the quasi-quote. Only in Dotty, it's not a quasi-quote. It's going to be this quoted expression, which is going to be that. So something like new quoted, and then it's just going to be AST equals to, we just wrote it out right here. So it's going to be this code here, or this quasi-quote here. And what these things actually mean, what both of them actually mean, is that there's some Scala syntax tree that does something like, let's say that this is actually apply, because that's how case classes are actually created. So let's do apply here as well. Or no, we have to do new. So let's just do that. Right, and then this, the actual Scala AST, is going to be something like new of I don't remember the, one second. I don't remember the exact AST. I think it's going to be new, and then it's going to be, it's going to be, select, ident, quoted. I don't think this is right, but something like this. And apply to, and then the apply is going to have a list of arguments, which is going to be list. And then it's going to be that, right? So we don't actually have to put that there. And then it's going to be something like entity of person. So that's going to be, how do you translate entity of person? So that's going to be, this is entity.apply, right? Because you're constructing an entity object. So this is going to be select, ident, and some package. And then it's going to be select entity from that, and then it's going to be apply a method on it. In this case, the apply method. In that case, person is an argument. Select, oh no, sorry, we're selecting entity from that, and then there's also another select here, I believe, and then apply, and then there's going to be another apply, which is going to be the list of arguments, which is going to be constant person, like that. Right? So this tree is what we actually need to shove into whatever output is coming out of this function. Oh, sorry, we need more, right? We need this whole expression, or this whole expression. So it's also going to be new of select some kind of ident, which is going to be a package, and then it's going to be, and then from there it's going to be, I think also select, I don't remember exactly, and then quoted, right? And then that whole thing is going to be apply that whole thing on the list of arguments, which is this whole thing here, or something like that, right? This tree, and I don't remember that this is exactly it, so we can actually look into what exactly the tree is, and not so important. This tree is what comes out of this, or what comes out of this, right? This tree is what we need to take and actually store inside of this thing that comes out. So that eventually this whole tree, which is the same as this, or the same as this, eventually gets passed into the run function. Now, here's the question. Again, how the hell do we get something which is of type AST that we've just returned from our parser? How do we get that actual stuff? How do we get this entity thing, which is this stuff here, right? Apply entity on const list person, right? That, right? This thing here is actually that, right? How do we get, I don't think we need that, no. Yeah, there we go. Right? This thing here, which represents that. How do we do that? How do we go from here, which is stored inside of some variable that our parser gives back to us inside the body of the macro, how do we go from here back to here? Or to this thing? Right? Well, which is this thing. Right? How do we do that? Does everybody understand why we need to do that?
Yeah.
Okay.
Although, never mind. I'm assuming you'll answer my question a bit.
Okay. Well, the answer to how we do that, the answer of how we go from here to here is basically this. We know every single possible thing that this could be. So we could simply write if Quill AST instance of what are all the possible things it could be. It could be an entity. If it's an entity, then return new entity. And what's inside? Well, what's inside of an entity is a string. So if this is instance of an entity, then we could take this thing and we could cast it to an entity and pull out the name of the table, which would be person. But again, not new entity. If we know it's an entity, we create a new quasi-quote, new entity, and what goes inside here? Well, now we know that it has to be some kind of constant. It has to be some kind of constant. And this is going to be this thing dot as instance of entity, and then let's say dot name is going to be person. Right? It could potentially be something else if Quill AST instance of, let's say, map. Well, then what we do is we say new, and we instantiate this thing, new map. What's inside of map? Quill AST dot, what do we put inside? Dot as instance of map inside. Well, an entity could be inside, so this whole thing needs to parse itself recursively. So let's say we call it let's call it liftable, or let's call it liftables. It takes an AST, and what it does says, liftables, let's do object liftables. It has this apply that takes an AST, and then it has this function inside. It has all of these if statements. If it's this, then do that. And what you have to do is you have to apply this thing recursively. And so we apply this whole thing recursively. So what we're able to do is we're able to basically enumerate all the possibilities of what the things in this AST that we've returned from the parser could be, and synthesize quasi-quotes for them. Except for the fact that, again, in Scala we have something better than if. We have AST match, right? Case entity. Name, quasi-quote of new entity name.
So where exactly is this apply called for the first time?
This apply called for the first time?
Yeah.
Well, when we return from the quotation, that's when it happens. So in this case, this is, and liftables is designed a little bit differently in Scala 2 versus Scala 3. I don't want to go into that now. In the Scala 2, it uses type classes more, but I don't want to go.
You're gonna have to. Yeah, I was just wondering where exactly it's called.
Now, here's where it's called. Here's where it's called. Remember this? Where we called AST parser? Right? This is the quote macro. This is the definition of quote. Well, here's the AST that we've returned from the parser. Right? This is this. Right? This is this thing right here. We also run through a round of beta reduction. Beta reduction just means like recursively substitute the values and simplify the AST. Don't need to talk about more of that now. Right, that's that. So here's our AST. Oh, look, reify liftings.
Okay.
That's where it actually happens.
That's what it's called.
A little bit more that goes on here. There are some other things that need to happen, but the gist of it is this thing does the lifting.
Let's see.
And then liftings is already the type of liftings. Is already tree.
Let's see.
In Dotty, this is not how you should actually launch it, but anyway. In Dotty, let's see, where's the quotation DSL? Yes, quote macro. No, sorry. No. Def quote. Where do I define this? Inline def quote. Oh, it is in here. There it is. Inline def quote. So there's our definition of quote. And then in this case, in Dotty, the grunt work is done by this object called quote macro, which is right here. And the actual implementation of quote is right here. And, oh, here's the AST parser. And then we do a few other important things. And then, ooh, there it is. Lifter, or liftables. In this case, we call it lifter. There it is. This is actually expression of AST. So lifter, surprise, surprise, goes from AST to expression of AST. That's a lifter. Parser, ooh, what does parser do? Parser, huh?
Was it a tree to AST? Was it the
but a tree is actually, yes. A tree is actually expression, or this is expression of any, but really this is expression of AST. Or this is, excuse me. This is expression of What it really is expression of this. Right? What is parsing? So lifting, which is what we just walked through here. Lifting is when you go from AST to expression of AST. Parsing, which is mainly what we're going to work on, is where we go from some kind of T. Really, it's more specific than that. Really, it's going to be like T is of subtype query, really. So we can just say it like that. Really, it's T, but whatever. To some kind of expression of AST. Finally, there's one more thing that you can do. There's one more thing that you can do, which is unlifting, which is the opposite of lifting, which takes you from an expression of AST to AST. So that's what these three things are. Unlifting is when you need to do the opposite of what we're doing here, where you start with an expression like this, and you need to get an AST out of it, which is actually very similar to parsing, right? Except for it's actually easier, because you know that what you have is a legit Quill AST to start with. But anyway, so we have, in order to get from this kind of construct here that comes out of the parser to get an expression that we can then plug into, like this thing, that we can then plug into the output of our macro, which is going to be something like that, right? Or something like that in Dotty. What we need is this thing called liftables. And we need to implement something like this. Now, most of liftables, right, looks something like this. We actually look at liftables inside of here. Or in this case, it's called lifter. So what lifter does, and we use some type classes here. We can brush up on type classes another time, but basically the idea is, if it's a map, yield an element which is going to be a map. If it's a map, yield an element which is going to be a map, right? This isn't a quasi-quote. This is Dotty, so this is a quoted block. Oh, but wait a minute. We need to recursively apply it, right? Quill AST, liftables.apply. Or in this case it's called lift AST. So we have to recursively apply it. If it's, what else can it be? Do I have filter here? I don't think I even have filter here yet. Anyhow, there's your lifter.
But this still feels like the parser.
It's very similar, except you're going the other way. You start with an AST element, you return a tree that contains that. But yes, you're right. It feels very much like the parser. And by the way, all the same kinds of principles apply. And my sincere hope is by the time you've seen all of these things, like by the time, we've been looking at these things into October, you will have seen this thing so many times that you are bored of it. Right? Like that, that's how you know that you've mastered something, when you get bored of it. Right? So, right there's our lifter. There's our parser, and we parse all of the different clauses. And then here's our unlifter. And ooh, this really is starting to look like the parser, right? We're actually parsing an AST element and returning an AST element from there. Right? This looks almost exactly like the parser. So, like, half of Quill is literally this sort of pattern. Match this, return this, match this, return this, match this, return this, right? Half of Quill is just this pattern over and over and over again. So, if you're starting to think that you're getting deja vu, that's a good sign. That means we're getting somewhere. So anyhow, but the idea is that we need to have some kind of way, to go from an AST element into the lifted version of that AST element. So if you look at what we did yesterday, we started going in that direction. What we did was we started implementing this sort of very simple Quill DSL. And then we started getting into all sorts of nitty-gritty details. So let's try this again. Let's have another go of it. But first of all, before we do that, sort of any questions?
No, none here.
Yeah, I'm good.
Okay. One second. I actually want to put socks on because I am getting cold. And let me just check something quickly. Later. Okay. And sorry, one second. Oh. Okay. So let's try to implement something like quoted. Let's try simple quill package org stuff. Okay. Case class quoted. Well, quoted needs to have stuff inside. Right? Quoted needs to have some kind of AST. So let's try and, well, normally we have a Quill AST, but let's make a super simple one. So let's say sealed trait AST case class. Let's just make one thing, which is called query, or sorry, an entity. This is going to be the name, which is going to be the string. That's the only thing we'll put there for now. We're going to have quoted, and quoted is going to have an AST. Okay. Well, now we actually need to define our quote macro. Okay. Okay. Let's define our quote macro, which is going to be object. Let's call it our DSL. And then spaces. And then we're going to have, let's say, inline def quote. Going to take some kind of type. And then inside of here, there's going to be some kind of expression of type D. Or let's say, inside of here is going to be our query. Or let's just call it our quoted content. Okay. So, right, there's our, and then the way that it always works is that you need something like quote impl, and then that's going to be of type T, and then we're going to pass quoted into here. Right? And that's the same thing as saying that. So this is already inside of the macro. So again, this is like the header, so to speak. This is like the header of a macro, or the header file, or however you want to call it. Let's define quote impl, and then T. Now we want to have some information about this T. So let's do type. Actually, instead of using this syntax, let's use the other syntax that I'll show you in a minute. The older syntax. We need the actual quoted, which is going to be our expression of T. But we need to do some imports. Import scala.quoted. And this is going to be quoted, which is going to be of type expression of T. And then our implicits, or givens in Scala 3, it's going to be, sorry, it's not given, it's using, whatever. They keep changing the syntax. Let's do implicit. They keep making it better, but they keep changing it. So anyhow, QCTX, which is going to be quote context. Sorry, this is just some ceremony that's needed. You just need to do a quote context because that stores all the information about the macro internally. And then here's the important part. Let's say type, or let's say T, which is going to be type of T. Now, if quote, what is this? Quote, oh, sorry, quoted context, quote context. Oh, by the way, if you don't recall, this is the same as that. And FYI, if you need to get back your T variable, you do val T equals to implicitly type T. Or, in Scala 3, summon. In other words, summon an expression of this type. Martin Adursky, who created Scala, basically has a very apt description, which is that what implicits ultimately do is they resolve some type to some term. That's what types actually are. But anyhow, let's, yeah, I think we'll leave it like that. So, now, let's, oh no, we actually do need this T. And what we also need to do is we need to, what comes out of this? What comes out of this is going to be what comes out of quoted. Right? What comes out of this is quoted of T. Right? Well, we need to actually put a T there so that we could return it that way. Just like the input argument, T becomes expression T. This becomes an expression of quoted of T. Okay. So, oh, a little bit more ceremony. Everything here in the implicit stuff. I think that's how that's done. I don't remember off the top of my head. I think that's what it is. Okay. Yes. There's some additional ceremony. The reason why this type here started being annoying is that part of the imports here is type. And so there is a scala.quoted.type that we've imported from up here. And there's also a qctx.tasty.type that we've imported from this, which is annoying. And so what you can do to make them different, you can do type t-type or tasty type, and then you no longer have a problem. If you don't do this, then it says, whoa, that's a problem, because this type in here that we've imported here doesn't even take a type parameter. It doesn't have a hole, right? But what do you call this? This is like a type hole. This type in here doesn't even have a type hole, right? This type that we've imported above in here has a type hole. This one doesn't even. So this statement even fails. So that's why, again, you can say, no. The type that's inside of this package, rename it. And I do this in a bunch of places. Anyhow, so just more ceremony that's required. So let's get to the interesting stuff. What is coming in through here? Right? Because somewhere in his client code, the user is going to do something like import DSL dot something, or dot everything, quote of query of T. Well, we need to actually define that. Okay, let's define query. Define query. Now query has a T, and query returns a query of T. Actually, it's entity query, but again, we can gloss over that detail for now. And query of T, we need to actually implement this. So let's do class query of T. Right? That's this thing here. Ooh, what's the implementation of this? Well, what happens to this? What happens inside of the quote block? Thoughts?
Supposed to remain as just as a tree, right?
Yeah. So what's the implementation of it?
I don't know, should there be if it's not executed?
Ding, ding, ding!
Oh, okay.
Right? That's what really the user should know, right? You can't just do DSL.query, right? If the user tries in their user code, if the user instead of doing this tries query or DSL.query, that's not legal. Okay. And actually, this argument that we had here really, that's what we should be writing for all of them. This can only be used inside a quoted block. Oh, and since we very nicely wrote all these methods here as our query DSL, why don't we put them over here? Right, because we already worked on that. Let's see, what did we do wrong here? Is this policing our indentation? It is. So there will actually be an option in Scala 3 to use significant white space, like Python. Half of the Scala community is like, yay! The other half is, nay. Which is why it's optional. But if you have formatting differences, like tabs in one place and spaces in another, it'll just give you a warning. Oh, your indentation is off. Okay, whatever. Either you love it or hate it. But anyway, so now what we need to do once we have this, and we have this, and this is our query DSL, well, then our user can already do something like val q equals to quote query of person, case class person, name string age int, dot filter. Well, let's actually just start with this. So, what do we need to return? Well, we need to return some quoted of t. That makes sense. So, return some quoted. Let's do null for now, which is not good, but whatever. Okay. So the first thing that we need to do is to parse this. Ooh, but we want the stuff to be passed here itself to be inline, remember? Right? That's how we get the actual syntax tree. And we also want, let's call this quoted, yeah, or fine, let's say quoted raw, which is the real thing, which is going to be quoted dot unseal dot underlying argument. But that's going to give us a term. And no, we actually want to be able to match on an expression. So we seal it back up. And this gives us what we want to be able to parse. This is just sort of more ceremony that you have to do. And again, look back to some of what we discussed last time, right? In order to get the actual, remember when we had all those, nested inline like objects that we needed to then collapse, right? That's what this whole thing does. So let's write the parser. So we can define it. Let's define the parser. The parser, or let's do object parser. It has a apply method. Or let's actually, yeah, let's do it like that. Parser. And what does the parser do? It takes some kind of tree, expression of any, in this case, because this is what we're going to pass inside. And what does it yield? It yields an AST. Okay. Let's give this a shot. Expr match. Let's see. Case. Let's try to parse it. So, try to parse. Let's actually pull this out and let's. Yeah, this should be fine. Case DSL dot query of some kind of type. And then when we have this, stuff can presumably come after it. One second, let me just refer to ksdsl.query of t. And here this is done a little differently, but oh yeah, query of t and yeah, that's fine. That's fine. And I think I'm missing something. Oh no, that's fine. Query of t. DSL.query of t. Yeah. So let's parse this. Now, what's the type? So we want to know what this is. Well, we should be able to get it. How did we get it? We took this T and we had query schema. What did we? Oh no, no, we wanted that. We wanted that. Where is T? Oh, here we go. There. So we need to do a couple of things. Unsealed.classSymbol.get. Okay. So we need to do a couple of things. What's this? This is a scala.quoted.type that we can then unseal, which will give us oh right. Null, so it doesn't complain about that. It'll give us this thing called type tree, from which we can take a what was this? The actual type, which is, surprise, surprise, one of these. So this is actually the element which is a type of the AST. Like when we have something like select ident DSL query and then it's query of t, so it's going to be type apply list of arguments type t, which is going to be person. So this is already what happens in the Dotty type tree. So this pulls that off. So now this thing has a bunch of fields. And then there's this thing called the class symbol and some other things that you can pull out from there to get the name of it. So this is going to be the name of this thing. And that's all that we really need to return an entity of this. So now, and that's it. Oops. And then let's, val output. Return output, except for the fact that you don't need to do return. And really, if we're returning just the result of this expression, we actually don't need this variable at all. We can just do that. And then we're good. So now, val Quill AST is going to be parser.apply of this thing here, quoted raw. Okay, this is of type AST, but remember we had this problem where what we need to do is we need not AST, we need expression of AST. Well, that's an issue, right? We need to have an expression of AST that we can plug into there. So now we need to write the lifter. Lifter def apply. This is going to take a expression, or sorry, this is going to take an AST, and it's going to return an expression of AST. What is it going to do? Well, it's going to do what we have here. So, in this case, the only thing that we have, the only thing that we've defined so far that an AST could be is an entity. So, case entity name, excuse me, AST match case entity name, and let's define what needs to come out. Entity and name. We need to plug this string directly into there. Let me actually just very quickly look at how I did that. Name string, name.liftable. Oh, and I defined, okay. I'm using some type classes here, but ultimately for now we can just do expression of name because you can and then you have to do that. So really what's going on here is that we're saying name expression is that. Oops. Name expression. So this name is string. Name expression is Expr of string. And we can, certain things, we can lift by doing Expr of that. And then we just take this thing and splice into that, right? This is like saying unquote, right? We are taking this thing and we are splicing it in. Really, that's that, but again, you don't, when you're not doing dots or anything, you don't need that. You can just do it with a $sign. Right? So that's that. Right? Or again, like I showed you before, you can just put this thing directly in here. But we'll keep it that for now. So, okay, so we have a lifter. So let's do val lifted AST is going to be lifter dot apply of Quill AST. Now this is going to give us an Expr of AST, which we can very nicely lift into our expression that comes out. And this is basically Quill. From the beginning of this thing to the end, this is basically Quill. At least not including the query transformations and other kinds of constructs and all sorts of other important stuff, but in some ways those things are all details. Or this is, I wouldn't say it's Quill, it is the quotation mechanism of Quill, which is mostly what we're going to be working on. Like Quill is really three things. It's a quotation mechanism, it's a query compiler, and it's a query executor. It's three things. So for Dotty, all of the query compilation, which is the transformations, those are staying the same. The execution is basically staying the same, but it's the quotation processor. That's what changes. So the quotation processor is this. This is basically an implementation of Quill's quotation. Does that make sense?
Mm-hmm.
So let's see if we can actually run it. And they're going to be, or let's actually try to compile it first. Okay. Why did it go back to 4 spaces? Oh, we actually have never defined any object or package called simple Quill 2. This call is flexible that way. You don't need to name the class the same thing as the file. So let's do import DSL. quote, query, and let's do case class person name string query of person. And let's see, or once we have this, let's print, let's do inline def, right? So that we can actually get the content of this. And let's print it. Do I have a printing macro somewhere in here? I have a printing macro. My first macro. Basically I use certain macros just to print stuff. Do I have a printing macro? I don't think I have a printing macro. I want a printing macro to just print this thing. So I want to know what the or we can, for starters, we can just do print line of Q. That's simple enough. So let's compile, run main, org used simple Quill 2. Voila! There we are. And everything works. This is actually rare. It is rare for everything to work the first time. Do not expect it to work the first time at all, ever. But yes, it looks like it worked the first time. What I want to see, though, is I want to see the raw Scala AST of this thing. So let's actually let's write a quick printing macro. And what this thing is going to have, object printing. So just let's do print mac. And let's do def inline def print. It's going to take anything, right? Because we don't care about what the contents are. We just care that we want to print the macro. This is going to be inline. And this is going to be, it's going to return anything also, because we really don't. Actually, no, let's return nothing, because, again, this is just for the sake of printing. You could also return the same expression from the macro, right? Whatever, it doesn't really matter. And this, let's implement this, right? This will be print impl. And this will take, just pass any into there. And then it will be def print impl. And it will be expr of any. And it will return expr of unit, because we don't care. No, we need to return, we need to import scala.quoted. And what we need to return is an expression of unit, which is going to be that, or actually in Scala it's that. That's an expression of unit, which is nothing, right? Because what you could do in Scala is you could do, def blah unit, right? And then you could do that, or return that. Which is the same as that. It's return unit. You actually don't need to say it specifically, but I think you do for a macro. I'm not 100% sure. I think it's needed. Oh, again, we need to have some ceremony. Implicit QCTX, quote context. And then let's do, all right, more ceremony, QCTX dot pasty dot blah, given blah. Let's do, we do get, no, 1 second. Do I have pprint here? I have pprint. So let's do pprint, or print line, pprint dot apply of Expr dot show raw. Oh no, let's do Expr dot unseal dot underlying argument. Right, in this case, we're not even going to seal it back up. Right, we want to see the unsealed AST. By the way, we actually, like, in the client-facing code, right now we would have to do something like print mac dot print and then our AST in here, or our quoted in here. But if you actually want to be able to just do print mac like that, that'll be the same thing as print mac dot apply. So we can actually change this to apply, and you just do print mac. Does that make sense? So in Scala 3, the name of the macro method and the name of the implementation do not actually have to be the same. Anyhow, so, and by the way, this function can come from any static object. Like, you can define some object somewhere to do that method that you're going to call, which is actually the pattern that I use relatively frequently. So if you look at DSL, for example, def quote, right, I actually do query macro. This is query macro to apply. Same thing. Right, so I call apply on a query macro, which is somewhere else. And I like to use this pattern because it lets me separate the implementation of macros from the definition. Anyway, just other organizational details. So now let's do print mac of q. Print mac of q. And do we need to import it? Oh, printing macro. That's fine. This thing doesn't need to be the same as this object. Print mac. Print mac apply. It's in the same package path. Let's see. Compile. Oh, important to note. Sometimes, this is, again, the entire IDE plugin for Dotty is sort of experimental. So sometimes, actually, frequently, it will tell you something that's underlined which is wrong that isn't. And you don't actually know until you compile the whole thing. So just word of warning. Sometimes the errors that it shows are not real, and sometimes there are errors that the underline doesn't show. So just an annoying thing to keep track of. Anyhow, so what happened here? Okay. Remember how I tried to actually define what the tree of this thing is, or what the tree of this thing is, right here? Right? Well, this is it. This is the actual tree, right? This is the actual tree of the quoted expression, right? This here, this is the actual Scala tree of that. And then let's see. Let's see how wrong I was. Okay, apply type tree. Okay, this stuff in here. Oh, sorry, it's not type apply, it's typed when you're applying a type to something. And there's going to be a bunch of ceremony inside of here. So in fact, this thing here is actually going to be not list, but it's going to be applied type tree, and it's not just going to be person. If person is a subclass of other things, there might be other things like type, ref, package, or some other nonsense in here, and that's what all of this stuff is. It's just the type tree of quoted. Right, so this thing here, right? This thing here is the type tree of this. And so apparently in the type tree, because we did, right, whenever we do unseal.underlying argument, it always turns an entity, it always adds a type ascription. So this is going to be like quoted of entity. Quoted, and again, the quote is going to be the, well, really it's, because if we're keeping track of the type, it's the quoted that was passed in. So in this case, it'll be query of person. But again, the type here actually doesn't matter in terms of the AST inside. Because again, we don't actually do anything with this stuff, right? The type that's in quoted results from this expression, but we don't do anything with this expression other than parsing it to an AST. Right, so this is going to be like a quoted query of person, right? Which means that all of these outputs, this is actually going to be that. Right, this is actually going to be that. This is going to be that. So that's, and then because we did unseal.underlying arguments, it adds a type ascription or type apply. Actually, no, there's type apply, which is separate. Oh, okay, excuse me. Type, oh, no. I got mixed up between two things. I'm sorry. Type apply is the example that we had, where's our type apply? Type apply is this, right, where we have query of T, right? So this, right, it could be query of foo, right? And it would be something like DSL.query of foo, right? And the AST that would be that would be something like ident DSL. Again, let's just forget about that. Select query, and then if it's foo, right, there'd be apply, and it would be a list of foo. Let's say it's another ident, right? But it's not that. It's actually, let's say, person. So this is going to be type apply, and it's not going to be list. Is it going to be list? Type apply. Yeah. type apply. Yep. It's going to be list type foo. But it's actually more complicated than that. It's like type tree of, depending on some other things, it'd be like type tree of type ref of some other complex garbage. This type, which is if there's a this pointer involved, whatever, just more complex garbage to describe the type. Like when you see something like this, just go all the way to the end, blah, 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 org, right? Because typically it's not going to be just person. It's going to be something like org.stuff.person, which is the package. So that's where, oh, okay, it's type ref of org. So it's going to be type tree of type ref of org. And then inside that, there's going to be type ref or something like that of stuff. And then inside there, it's going to be type ref of, finally, of person. And there could be some other stuff in between. So this is all just a bunch of garbage to fully represent a type. But anyhow, so that's what type apply looks like, roughly speaking. Let's just take this and put it into a new area. But anyway, what happens is that in this case, here, this is going to be the actual tree. This tree here is going to be quoted, and then quoted of query, and this is going to be type apply. So that's going to be something like, oh, there we go, select ident quoted, and then let's leave that alone for a minute. Type apply, and then there's going to be like all, right, this whole thing here. So it's going to be type ref, and then it's going to be like, or type tree, and then inside of the type tree, there's going to be a applied type of some kind, more garbage that you don't care about. Type ref, and then it's going to be of the fully qualified path to this. So org.stuff.that, org.stuff.that. So now we're going to have a bunch of nested type blocks to represent this package. So org, and then there's going to be another type ref here, which is going to be stuff. And then finally, there's going to be a type ref, some other garbage in between that's finally going to be. That's what all this garbage is. So this is the applied type on quoted. So this is that. In particular, all the stuff inside here, blah, 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 all of this stuff here, all of this stuff here is just that. And then this here, right, this is going to be quoted dot apply, and then these are the arguments of quoted dot apply. So this whole thing here, sorry, type apply, so this whole thing here, type apply is that. And finally, out here, apply is going to be and it's not this, it's that, actually. So this is that. And so finally out here, it's going to be this whole thing, right? Because then these are the arguments that are the list to apply, right? What are the arguments that are getting passed to apply? Like, what are the actual arguments? Well, that's this stuff here, right? So this stuff here is that entity.apply of person. And then finally, all this stuff here is this type ascription. So this, that's what typed is when there's a type ascription, like when there's something like, let's say, 5 for int. What is that going to be? That's going to be something like typed constant for int. Something like that. Again, there's probably going to be like more complexity. By the way, if you want to actually find out what it's going to be, again, you can just call this print mac. Like, in general, if you need to look at what a tree is, and this is what I do all the time, and when I talk about actually how to write these parsing clauses, the vast majority of it is trial and error and looking what print mac for a particular statement is. So let's say for int, right? Let's say compile of that. Oh, there we go. Typed literal of 4, literal constant, same thing. Let's see, what's that? Okay, that's just literal of 4, right? And so this is typed. This is a type ascription, right? Long, same kind of thing, right? So that's what typed is. But anyway, so the type ascription, this whole side of it, that's going to be this whole thing here. Which again, it's actually going to be org.stuff, and that's why they're all of these nested types, because each package is a nested type, and there's even this thing here, which is a synthesized class because the file is named that, which is like JVM stuff, whatever. That's more stuff that you really don't care about. But anyhow, so this is the tree that we have ultimately yielded when we returned this thing out of the macro that we wrote, which is this guy over here. So this is Quill's quotation mechanism. In a nutshell, everything else is details, and there are a whole heck of a lot of them, and in the coming 2 weeks, we'll go into some of those.